All right, guys, lesson 4.7 is perpendicular bisectors on triangles. Remember, yesterday was angle bisectors. So this is more cutting the sides in half instead of cutting the angles in half. So it will give you a particular type of triangle to draw. I'm just going to do an acute scalene. So try to make it so all the sides are kind of different and all acute. So maybe just a random triangle like that is fine. So it will ask you to draw a particular type, isosceles or something like that. Mine is just acute scalene. And then it will say draw the perpendicular bisector of each side. Perpendicular, remember, means 90 degrees. Bisector means cut in half. Or find the middle, really. Find the midpoint, okay? So cut it in half at 90 degrees. You gotta do that on each side. So take it a side at a time. This side, I'm just gonna do it with a ruler. So it's about, say, 12.4. So half of that's gonna be what, 6.2. Yours, obviously, if you're doing the notes here, won't be the same as mine. That's okay. So take one of your sides, find the middle. I've got to go through at 90 degrees. You could use a protractor to make a 90. Another easy way is take something like a card or something, maybe one of your Christmas cards there, and just use that as a 90-degree corner. Okay, so that would be the perpendicular bisector right here. Extend it out like that, 90 degrees. Do that on each side. So take this bottom side and find the middle. Mine is about 11, say 11.8. So half of that is what, 5.9, I believe. That's the middle. And then make a 90 degree. And then I'll do that last side, find the middle. About 9, say 9.4 is what, 4.7. Middle, 90 degrees. If you were good, they should all meet up at a single point. See how good I am? I am not very good. Okay, well, they should have met at a single point in here. All right, so I made a mistake somewhere as far as finding the middle, or maybe not making a nice 90 degree. This 90 degree I feel like was off a little bit, honestly. It's pretty good. But maybe if that was over just a little farther, you know, they would have met up nicer there. Okay, but your goal is to get them to meet up at one nice point. That point where the perpendicular bisectors meet, at it's called the circumcenter. Okay. The other thing is this. There's a property of that circumcenter. It's equidistant. Remember we said equidistant means it's equal distant to each vertex. Remember, vertex is just a corner. Okay, so equidistant to each corner. So this point should be the same distance to this corner as it is to this corner and this corner. You could measure it with a ruler, but kind of a cooler way to show that is just to draw that circle again. Just draw a circle centered here, that the circle should go out to here, so the radius of the circle goes to the corner. All right, so I'm gonna try to do that here. And my point, I'm gonna kind of guess, okay, maybe in the middle of that blob I made, that maybe is close. Hopefully we'll see how it comes out. So if I go around from one of the corners, oops. Okay, it should hit each corner. I kind of flubbed up here, but you see that hitting, and hitting over here. So that shows, right, that's equal distance from here to each corner of the triangle, because I can draw that circle that hits each corner. Kind of a cool property. Say, for example, these are three cities, city city A, B, and C, and I say, hey, where's a point that's the same distance to each city? Where's that single point that's the same distance to, you know, Fowler, Puamo, and Westphalia? Well, you could do this on a map, do the perpendicular bisectors of this triangle, and you could find that point that's actually the same distance to each city, and then maybe erect a statue of a famous person from those cities. Who would be the most famous person from Puamo, Westphalia, and Fowler? I don't know. Okay, have a good day, guys.